students, welcome to mathgotserved.com. In this clip, we're going to be going over how to factor quadratic expressions. Alright, the instructions for the examples that we're going to be doing are as follows. We are to factor the following expressions, factor the following expressions, and check by expanding. Okay, check your answers by expanding. So we're going to factor the expression, and then whatever result we end up with, we will check the accuracy of that result by expanding the factored state. Now let's take a look at question number 1. Let's say we have the following quadratic expression, x squared plus 6x. Alright, so the first thing we're going to do is we're going to see if there's if there's a common factor that we can extract from these two terms. We have a total of two terms here. So let's go ahead and decompose both terms. X squared can be broken down into x times x. So that's a decomposed form, x times x. And then we can break down 6 using the product of primes, okay? So what is the prime factor decomposition of 6? To do that, let's go ahead and review our primes real quick. Then we'll go ahead and factor this. What are our list of prime numbers? Our primes are 2, 3, 5, 7. The list of numbers that are divisible by 1 and themselves only, those are prime numbers, okay? So 2, 3, 5, 7, 11, and the list goes on and on. So when you're decomposing numbers when factoring, you want to ensure that the product of factors are only prime numbers. So let's use that idea to factor 6. If we factor 6, since it's even, we know that 2 definitely goes into that 3 times. So this is the factored state of 6. So we can write this as 6x can be written as 2 times 3, the decomposition of 6 times x. Okay? Now we have two terms separated by this plus. They have been decomposed. So the question now is, what can I factor? What's common to both terms? We notice that x is common to both terms, so I can factor out an x and an x. When I factor out a term, it is as though I am dividing by the term that's factored out. Okay? So let's go ahead and do it. If we factor out the x, you have an x on the outside. And then what happens is as though these two x's are canceled out, and we're left with x plus 2 times 3, which is 6. So there goes our final answer for question number 1. This is the factorization of x squared plus 6x. Now let's go ahead and check to see if our answer is in fact correct. Okay, so we're going to check by expanding. So we have x times x plus 6. So all we simply do here is just distribute this x to x and positive 6. When we carry out our distribution, we're going to end up with x squared plus 6x. And this matches the original problem we were provided with, so we know for sure that our answer is in fact correct. Alright, let's take a look at question 2. What if you have the expression x squared minus 9? Okay, so if you have x squared minus 9, how do you factor something like this? Now, is there a greatest common factor I can extract from these two terms? What we'll do first is we decompose both of them. X times x minus decompose 9. Using our factor tree, we'll have 3 times 3. What you find out is that there's no common term that can be extracted from these two terms. So what we will do is combine them back. X times x is x squared. 3 times 3 is 9. Now there's a special formula that can be used to factor problems of this nature, and that is known as the difference of squares formula. Okay? Difference of squares. The difference of squares formula is as follows. If you have to factor the difference of two squares, a squared minus b squared, what you do is you take the square root of the first term and the last term, and then you express it as a sum and a difference. Okay, so this is going to become a plus b times a minus b. Okay, now let's take a look at this problem we have here. Is x squared a square? It certainly is, since x is being squared. How about 9? Is 9 a square? Let's take a look at a list of some of our squares. So what is the smallest positive square? 1 is a square because 1 square is 1. Can you think of the next square after 1? The next square is 4 because 2 square is 4. Next one is 9 because 3 square is 9. We have 16, 4 square. So these are square numbers. They go on forever. Okay? Now, is 9 a square? It certainly is. If you look at our list right here, you notice that we have 9 as the square of 3. Okay? Alright, so we can apply the difference of squares formula here because we have two squares and a difference. Remember, difference is the subtraction operation. So what we do is we take the square root of the first term and the last term and express that as a sum and a difference. Okay? So this is what I'm doing. I'm going to set it to the side here. I have a square is equal to x squared, and b squared is equal to 9. We have a squared and b squared because we have two squares. When you take the square root of both sides here, what do you get? You end up with a is equal to x. How about on the other side here? If you take the square root and the square root, you end up with b is equal to 3. Okay? Now we're going to express this as a sum and difference of squares. We're going to have x plus 3. This is a plus b times x minus 3. This is a minus b. Following the formula, a plus b times a minus b as the expanded form of a squared. This is like a squared here minus b squared. Okay, so our final answer is x plus 3 times x minus 3. Now, is this answer correct? Let's go ahead and check again to see if our factorization is in fact accurate. So, we'll check by expanding. We are multiplying x plus 3 by x plus minus 3. Let's see if we end up with the original problem. So you distribute this x to x, and then x to 3. You then distribute 3 to x, and then 3 to negative 3. Upon multiplication, what do you get? You end up with x times x is x squared. 3 times x times negative 3 is negative 3x. 3 times x plus 3x plus 3 times minus 3 yields negative 9. Can this be simplified? Absolutely. The middle terms add up to 0, so they cancel out. So we're left with x squared minus 9. Is this the original problem, the original expression we were asked to factor? It certainly is, so our answer is correct. All right, let's try another difference of squares example. Let's say we have something like this. Let's say we have, um, for number 3, 4x squared minus 25 as the expression to be factored. If you decompose this completely, we have 2 times 2 times x. Decompose 25, you have 5 times 5. What you notice is that there are no common factors. So we reunite them by multiplying back 4x squared minus 25. Now, do we have a difference of squares? Is 4 a square? It certainly is. 2 squared is 4. Is x squared a square? It is. So the product of two squares is always a square. So this is a square here. And then 25 is also a square. So we can use the difference of squares formula. So what we're going to do is take the square root of the first term and the square root of the last term and express them as a sum and difference. Okay? So in this setup, a squared is equal to 4x squared, and b squared is equal to 25. So what we're doing is taking the square roots. Okay, take the square root, take the square root, square root, square root. And then we're going to have the result that a is 4x. No, it's not 4x. A is 2x. You root the 4 and the x squared. A is 2x and b is 5. We're going to now write the sum and the difference of the square root of the squares. Applying the difference of squares formula, our answer is going to be a plus b, which is 2x plus 5, times a minus b, which is 2x minus 5. Okay? That's our final result. Let's go ahead and do a check to see if our answer is in fact correct. Okay? Now we're going to distribute again. We have 2x plus 5 times 2x minus 5. When we expand this out, just distribute 2x to 2x, and then 2x to negative 5, 5 to 2x, and then 5 to negative 5. Let's see what we get. We end up with 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 5 times 2x is plus 10x. Negative 5 times positive 5 is negative 25. The middle terms are opposites of one another, so they cancel out. And you end up with 4x squared minus 25. And this is exactly what we started with, so our answer is correct. All right, let's take a look at the last example, question number 4. So for problem 4, let's say we have a quadratic trinomial. Now, x squared plus x minus 30. Okay? Now, first of all, we can see that there is nothing to be factored from the three terms. Okay? This has no x in it, so there's no common factor that can be taken out. So how do you factor something like this? When you have a trinomial, the goal is to break it into 4 terms so that you can factor by grouping. We need to find 2 terms to replace the middle term with so that when we factor by grouping, we will be able to have identical factors to pull out from the pairs. We're going to use a method called the X game or the AC method. Some people call it the diamond method, whatever you want to call it. I'm going to call it the X game. So in this setup, we have a, b, and c. Okay, so a is the coefficient of x squared. This is b, and that's c. So a is 1, b is 1, and c is negative 30. We're going to play the x game. We're going to put a times c on the top and b goes on the bottom. A times c is negative 30 and b is 1. Now the question is, what two numbers do we multiply to get AC, negative 30, and add to get 1? So if you can think of it, that's great. If not, you can make up a list of product of integers that yield 30 and then exhaust the combinations to see which one will give you the desired sum or difference. Alrighty, so we have 30. What pair of integers multiply to give us 30? 1 times 30. What else? Does 2 go? Yes, 2 goes into 30 15 times. 3 definitely goes into 30 10 times. 4 doesn't go into 30. 5 goes into 30 6 times, and we have a complete cycle. Now we're looking at the pairs. Which pairs can be added together or subtracted from each other to get 1? Let's look at what we have here. 1 and 30 gives us 31 or 29. No good. 2 and 15 gives us 17 or 13. No good. 3 and 10 gives us 7 or 13. No. 5 and 6 gives us 11 or 1. We have a winner. This is the pair that we can use. Okay. All right, so let's put it here. We're going to put the numbers 6 and 5. But we have to make sure that the signs work, okay? Since the product is negative and the sum is positive, the smaller number has to be the negative 1. Okay? Now what you notice is that a is equal to 1 in this problem. Whenever a is 1, you don't need to factor by grouping. So since a is equal to 1, no grouping. No grouping method needed. Okay, we can just jump straight to the factored state, which is excellent. So what is the factored state? You just take x, extract the first result from your x game, positive 6, and then another x, extract the second number from your x game, negative 5, and that is our final answer. X plus 5 times x minus 5. Is our answer correct? Let's go ahead and do a check to make sure that our result is in fact accurate. So to check our work, we're just going to expand. Okay? So we're going to multiply x plus 6 times x minus 5. Just distribute x to both, and then 6 to both. If we expand it, we're going to have x times x is x squared. X times negative 5 is negative 5x. 6 times x is plus 6x. Positive 6 times negative 5 is negative 30. Okay? Alright, when we combine the two terms, we're going to have x squared minus 5x plus 6x is plus x minus 30. Is this the original expression that we have? X squared plus x minus 30? That's exactly what we have. So our answer is in fact correct. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your study of factorization, do give us a thumbs up. Your positive feedback is very important to us. If you have any questions or comments about the contents of this tutorial, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.